Okay, let's be real for a second. These two things, the Vernier caliper and the micrometer, are probably the scariest looking instruments in the physics lab. But what if I told you that in just the next few minutes, we can make reading them feel totally natural? Let's dive in.
I'm serious. Take a good look. If I handed this to you in an exam right now, would you feel that little bit of panic, or would you feel totally confident? Just be honest with yourself.
And that's the infuriating part, isn't it? You can know all the theory, you could be a physics whiz, but one tiny little slip-up in reading this thing, and poof, all the marks for that question are just gone. Well, not anymore.
And that's exactly why we're here. Welcome to Learn with Ease, where we take tricky topics just like this and make them, well, easy. Our whole goal is to take you from that, I don't get it feeling to, oh, I've got this, one simple step at a time. So today, you're going to master both of these guys, the Vernier caliper and the micrometer screw gauge. By the time we're done, there will be zero confusion, I promise. All right, let's jump into our first precision challenge, decoding the Vernier caliper. So you might be wondering, why even bother with this thing when I have a ruler? Great question. It's all about precision. A Vernier caliper can measure things a ruler just dreams of, like the exact width of a pipe, inside and out, or how deep a tiny hole is. It's for when close enough just doesn't cut it.
Now this formula right here, this is the golden key. Seriously, burn this into your brain because it unlocks every single Vernier problem. It's simply the main scale reading plus the Vernier scale reading times something called the least count, which is just a fancy way of saying the smallest possible measurement the tool can make.
Let's walk through one together. Step 1. Find the reading on the main scale that's just to the left of the 0 on the moving scale. In our example, that's 2.3 centimeters. Easy. Step 2, you scan along the Vernier scale until you find the one line that lines up perfectly with a line on the main scale. Here, it's the 6th line. So we take that 6 and multiply it by the least count, which is usually 0.01 centimeters. And for the last step, we just add them up.
And there it is. 2.3 plus 0.06 gives us our super precise answer of 2.36 centimeters. See? Totally doable.
Okay, awesome. You've got the basics. But let's throw in a little curveball that you'll definitely see in exams. What do you do when the instrument itself isn't perfect? We call this a zero error. All a zero error means is that when you close the caliper completely, the two zero marks don't line up perfectly. It's just a tiny flaw in the tool itself that we need to be smart about and correct for.
Now this is the part that trips a lot of people up, so lean in. The rule here is kind of backward. If the Vernier 0 is to the right of the main scale 0, that's a positive error, and you subtract it. If it's to the left, it's a negative error, and you add it. Just remember, you always do the opposite. Positive error, subtract. Negative error, add. So, for instance, let's say you measure something and get 1.58 centimeters, but you know the tool has a positive 0 error of plus 0.02. What do? You just subtract it. So your true reading is actually 1.56 centimeters. Simple as that.
Fantastic! You've officially tamed the Vernier. Now let's level up to its even more precise cousin, the micrometer screw gauge. This is for measuring stuff that's ultra fine.
You pull this tool out when even the Vernier isn't accurate enough. We're talking about measuring things like the thickness of a single sheet of paper or the diameter of a wire so thin you can barely see it. It's all about that next level precision. And hey, check this out. Does this formula look a little familiar? It should. It's the exact same idea as the Vernier's. Main scale reading plus the reading from the rotating part, called the thimble, times the least count. The principle is exactly the same. Okay, time for the boss battle. Let's put everything together. So, our main scale shows 3.0 millimeters. The thimble lines up at the 45 mark. We multiply that 45 by its least count, 0.01, to get 0.45. So our first reading is 3.45 millimeters, but wait, there's a negative 0 error of minus 0.03 millimeters. Remember the rule? For a negative error, we add.
So, we take our 3.45 millimeters, we add that 0.03 millimeters correction, and we get our final, perfect answer, 3.48 millimeters. And just like that, you've totally nailed an exam-level question. Before we wrap this up, let's do a quick lightning round of the silly mistakes that I see students make all the time. Let's make sure you don't fall into these traps. First, please don't forget to multiply by the least count. Second, if they mention a zero error, don't ignore it. It's there for a reason.
Third, watch your units. Verniers are usually in centimeters, micrometers in millimeters. And last, when you're stressed in an exam, double-check your addition. It's so easy to make a simple math mistake.
And here's a great way to remember everything. Just look at the two formulas next to each other. They're basically twins. It's always the main scale plus some other scale times the least count. Whether that's the Vernier scale or the thimble scale, the logic is identical.
And that's it. You made it. Let's just take a quick second to look back at everything you just accomplished on your journey to mastering this.
Seriously, think about how you felt at the beginning. That feeling is gone now, right? In just a few minutes, you've learned how to read a vernier caliper, how to read a micrometer, how to handle that tricky zero-error concept, and you've already crushed an exam-level question. That is a massive win.
You are now genuinely ahead of so many other students on this topic. So for your final challenge, go ahead and prove it. If a Vernier's main scale reading is 2.5 centimeters and the fourth division on the Vernier scale is the one that aligns, what's the final answer? Drop it in the comments below. If this helped clear things up, do me a favor and hit that like button, share it with a friend who's struggling, and of course subscribe so you can keep learning with ease. Catch you in the next one.